Welcome back to this third lecture on water conservation, where we are studying this ongoing online course on sustainable architecture. So, in the previous two lectures, we have seen what are the different components of water conservation in a sustainable building on a sustainable site. How do we reduce the amount of consumption of potable water and reduce the burden on municipal water sources. Next, we also saw how to harvest the rainwater, what are the different design strategies, what are the different calculations which are required to store this rainwater which is going to be harvested. Now, when we are talking about reduction in the consumption of water, we are going to talk about the reduction for irrigation requirement when we are talking about water. Often for large sites especially, water which is used for gardening, irrigation is a huge amount of water. It may not appear at the in the first, but eventually when we calculate the total amount of water which is going to be consumed by the building, we see that gardening or irrigation requirement forms a huge percentage of this total water requirement. Fortunately, the water which is required for irrigation is not potable. Even the treated grey water or the captured rainwater can very conveniently be used into irrigation without any filtration or treatment, much of it required, because it is non-potable use. However, even when we can do that, we have to reduce the requirement for irrigation. So, today we will be talking about water efficient landscaping. Now, before we go over it, let us quickly look at some of the terms and definitions which we will be using in today's lecture. The first one is drip irrigation. Many of you would be familiar with what drip irrigation is. What we do in drip irrigation is that we have these supply pipelines, small thin pipelines which are also perforated, which are buried in the earth, not too deep, but right beneath the surface of the earth, and they are continuously supplied with a low pressure water, and it continues to drip near the root of the plant. So, there are reduced losses from evaporation. The water losses from transpiration will be there, but the water losses because of evaporation from the surface of the ground, they are substantially controlled. The next we have is evapotranspiration. So, it is the rate of water which is lost from a vegetated surface, and it is in the units of water depth. So, it is expressed in millimeters per unit of time. So, suppose we have a grass lawn. Now, when there is a grass lawn, so the amount of water which is lost from that surface overall is the evapotranspiration rate. And when it is for the native surface cover, for example, no landscaping has been done and the ground is left as it is in a natural state. So, the amount of the rate of evapotranspiration is called as ET0, which is often taken as the base case. The next is grey water. So, as defined by the Uniform Plumbing Code of India, it is the untreated household waste water which has not come in the contact with toilet waste. So, it is used water, but it is not the water which is coming from the toilet. It is not interacted with the toilet waste. Next, we have integrated pest management. It is the coordinated use of knowledge about pests and the environment, pest prevention and the control methods which are going to be used. Now, the basic aim is to reduce the amount of environmental effects and also the economical resources. The next is micro irrigation, which involves systems like drip irrigation, sprinklers, micro jets, all of that together. So, that is called micro irrigation for a given site. Next we have native plants. Now these are the plants which have adapted to a given area. So there is a list of plants for every region, and we very clearly know, we have all read in our schools, that the conifer trees grow in the high altitudes, the flat leaved trees, they grow in the plains. So and trees growing in the coastal areas and areas which receive a lot of rains, they have very large leaves. So these trees have adapted themselves to the given area, and hence they have become native to the place. So every place, every geographical area has a list of these native plants available. The next is xeriscaping. It is a landscaping method that makes routine irrigation unnecessary. So that may be achieved through a combination of the selection of plants and also the selection of irrigation strategies. So suppose we have drip irrigation, and through that means the irrigation, the routine irrigation becomes totally unnecessary. So it is a combination of all these techniques which will lead to xeriscaping. It may also include a retention pond or many other strategies like that. So now we start discussing about reducing the landscape water demand. As I just was discussing about the xeriscaping, where the routine irrigation is totally eliminated, the need for it is eliminated. Now this may be through a combination of techniques. First and the foremost is selection of the plant species. So suppose we have a native plant which has adapted. So for such kind of a plant, even the rain which is there may be sufficient enough to irrigate it. In addition to that, we may plan for, say, a surface retention water body. With the help of this, the roots may draw the amount of moisture which is required for the growth of the plant. So a combination of these may result in a landscaping where we do not need to irrigate it at any point of time once it has fully grown. That is also our aim when we are talking about reducing the irrigation water requirement. So how do we do it? What are the ways in which we can achieve that? First and foremost is we have to minimize the lawn area. Lawns are water intensive. They require a lot of water, and they also require a lot of maintenance for their upkeep. Lawns just don't grow like that. Unfortunately, we in India are obsessed with lawns. How much ever maintenance and water they require, we are still obsessed with lawns. Lawns are good for some special purposes, for example recreational purposes, for example pedestrian walkways where pedestrians are going to walk. There the maintenance of lawns is good, grass lawns. However, in all other cases we can substitute the lawn areas with other species. So if we look at this, if we have 100% lawn, the total area of the landscaping covered with a lawn, then there is 0% of water saving. However, if we reduce the lawn area to 25%, we can achieve a water saving of around 48.5%, which is close to 50%, just by reducing a substantial amount of area which was going towards lawns. The next strategy is to maximize tree and shrub plantation. The moment we minimize the lawn area, we can increase the area for plantation of trees and shrubs. Now trees specially require very less amount of watering, irrigation, and also if the shrubs are carefully chosen, they also require much less amount of watering, because both of these are hardy species. They have hard stems and they lose less amount of water. Since they lose less amount of water, they also require less amount of water, and thereby reducing the demand of water for irrigation. The next is when we are increasing the area for tree plantation and shrub plantation, the trees and shrubs and all other plants which are going to be planted should be chosen as native trees and shrubs. For example, if you go to any hot, dry, arid area, you would find thorny trees, for example, kikar, babool, which is the common name, even neem for that matter. Now, these trees they have adapted themselves to survive in extremely hot and arid conditions. They take very less amount of water, they release very less amount of water through transpiration and evapotranspiration, so they lose it less, and that is why they require less amount. On the other hand, suppose we have an area which is very close to a natural surface aquifer, and there is a very high water table and there is a lot of moisture which is available in the ground. There, if we plant some such species, they may just die out because they are not used to, their roots are not used to so much of moisture and dampness. They may just totally die. So, in such cases, the plants which can survive in moist conditions will be required. So, we have to maximize the native trees and shrubs, and this substantially brings down the amount of water which is required for irrigation. The next, when we have even selected the species of trees, shrubs, smaller plants to be planted, we have to club them, we have to group them. We can't do that there is one tree and around that there are shrubs and then there are smaller plants, the ground covers. No, we have to group them. So, all these shrubs are grouped together, the trees are grouped together. Now, this grouping is on the basis of the requirement of water. So, the species which require more water are grouped together, the species which require no water are grouped together. In this way, the plants also grow healthily and the requirement of water for irrigation is also reduced. Next, we have this concept of xeriscaping. Now, here we design for a landscape which requires no irrigation at all. Now, it also depends upon the climate of the place. So, if we are selecting the native trees and shrubs, we are doing half the job there itself, because the native trees, shrubs, they anyways require no irrigation. They are surviving like that in the nature. Nobody waters them externally. They survive by taking up the water which is available in the ground, the moisture of the ground. They survive, when they receive rains. So, we are anyways doing half of the job when we are going towards xeriscaping, but in case it is required, then specific plants which require no watering at all throughout their lifetime, for example, cactus. So, different types of cacti may also be used. This is how we would go ahead with xeriscaping, and since the water is actually becoming a critical issue almost all over the world and we do not have enough water, xeriscaping is coming up as a very popular concept, and almost all the dry areas and hot areas are opting for this xeriscaping. Lastly, once we have decided and designed the type of plantation, the landscape scheme, we will then add in the last the irrigation system. So, we will choose the appropriate irrigation system. Now, there are different irrigation systems which are available. We have surface irrigation where we just flood it, which is the most inefficient way of irrigation because it results in huge evaporation losses and there is very little amount of water which is actually taken up by the roots of the plants. Next, we have sprinklers. We have multiple sprinklers where small sprinklers are distributed over the entire landscape, and last we have drip. Now, if we look at the efficiencies, drip irrigation has the maximum efficiency which is around 90%, while multiple sprinklers is around 75% efficient and sprinklers are around 62.5% efficient. This is an image which shows how drip irrigation was planned. Now, these pipes are visible because this is the initial stage of this landscape development. Later, when the plants and shrubs have totally grown up, these pipelines would not be visible actually. So, these thin pipes which we are seeing, these actually are perforated. So, they have small holes within them, and these holes allow for this water to release water very close to the root of the plant, which is immediately taken up by the root of the plant, and there is very less amount of evapotranspiration losses through the ground. So, an efficiency as high as 90%, which is very high. If we look at the green building rating systems programs, it could be IGBC, it could be LEED, it could be GRIHA. There are different types of compliance criteria here. Now, when we talk about this irrigation water requirement, the compliance criteria requires us to reduce this potable water consumption for irrigation by 50% from a calculated midsummer baseline. So, we have to calculate it for the midsummer, which is the peak hot and dry season, and from that baseline we have to calculate that how much of the potable water requirement for irrigation has been reduced. Now, this could be done through a combination of all the strategies that we have just seen. I will quickly list them again. So, one is with the help of selection of right kind of plant species, the density and microclimatic factor. Second is by improving the irrigation efficiency by selecting the right kind of irrigation technique. Third is through the use of captured rainwater. So, what we have already seen is that the rainwater can very conveniently be used for irrigation, because for irrigation it will not require any kind of cleaning or treatment. It could also be done through the use of recycled wastewater. So, all the wastewater, grey water and black water which is generated from the household may be treated, and then it can be used back into the irrigation system. And then use of water which is treated and conveyed by a public agency specifically for non-potable uses. Now, here in case the municipality has installed a big STP, and the treated water from that STP may also be supplied by a dual supply line. So, one supplies a potable water, the other supplies a non-potable water for non-potable uses. That may also be used for irrigation. So, by using a combination of these strategies, we have to show that we have reduced the water requirement for irrigation by 50%. Ideally, when we are talking about sustainable buildings, we should try to use zero amount of water for irrigation, and it is absolutely doable, practical, if we design right from the beginning, right from the concept stage, if we design our landscaping appropriately. So, what would we do? How would we know that what are the native species of a given place? The Botanical Survey of India has taken out several guidebooks where they have classified different types of plants and tree species for different zones, the agroclimatic zones. So, it is not just the climate, but it is a combination of climate, geography, topography, soil. So, all of that put together results in an agroclimatic zone, and for each agroclimatic zone there is a list of native species which is available. So, we should try to use the trees, shrubs, the species, plant species given in the native species booklet for the given agroclimatic zone. The next is we have to control and manage the invasive species. Sometimes a species which has entered into a new ecosystem is an alien species which does not belong, but since it is so dominant, it is robust that it flourishes, it captures, it changes, alters the ecosystem. We have to identify these invasive species and we have to control their growth when we are planning the landscape. For that, again we have to refer to the native species booklet which is published by the Botanical Survey of India. Now, this entire exercise brings about several benefits. There are environmental benefits to a tune of to an order which is very, very huge. Several environmental benefits. Now, this includes eliminating the irrigation needs, which implies reduced pressure burden on water resources. Then when we use native plant species for landscaping, it attracts native wildlife. It promotes to create a healthier, better ecosystem. The native species also require less fertilizers and pesticides because they have adapted to this environment. They have also adapted to the pests which are common to the given region. So, it requires less amount of pesticide and fertilizer to grow, and it also minimizes the water quality degradation because of all these previous reasons which I have just discussed about. It reduces the water quality degradation that might happen. At a large system level, because whenever we talk about sustainability, we talk about a long term plan, a futuristic plan on also large boundaries. We are not confined within our domain, within our boundaries. So, it actually helps to replenish and conserve the regional potable water resources. So, we are talking about creation of water bodies, surface aquifers as part of landscaping, which not only irrigates the landscaping, but it also helps in replenishing the regional water resources. It also helps in maintaining the water resources, water sources for future generations for a longer duration of time, as I was just discussing as a concept of sustainability. Besides environmental benefits, it also brings about the economic benefits. If we reduce the amount of irrigation water requirement, it implies that less amount of pumping will be required. It implies that less amount of energy will be consumed, less amount of treatment will be required. All of that implies that there will be saving of economic resources. So, when we are starting with it, we have already seen the different factors, we have already seen the different steps. How do we do that? So, we have to develop the site plan of the given project right in the initial stages and identify the different kind of strategies which can be incorporated, which can be used. It will be dependent upon, as I have said, different factors. So, it will be dependent upon the geography of the place, topography, climate, the type of soil, and also the type of plants which are available, and in addition to that, the kind of buildings which are going to come up. So, how much of the ground is going to be covered, what is going to be the height of the building. So, suppose there is a tall building which is going to come up on a particular site. Now, planting vegetation in the shadow side of that building may result in a lot of extra maintenance and care that may be required. So, we may push the building to one corner and allow landscaping in an area which is likely to receive more amount of sun. Now, then it will not be limited to just your own site, it will also be we will also be considering what are the different types of buildings which are surrounding the site, what is the height of these buildings, what is the shadow patterns, so whether the plants would receive enough sun or not. So, can I plant a certain species in a shaded area, shaded portion? So, I might actually require to select species which thrive well in a shaded portion. So, we identify the different types of strategies which may be used on a particular site. So, once we have made a note of all these strategies, then we start to design, then we start to plan them on the site, assign them spaces depending upon the slopes and all these factors. So, we have to identify these spots. For example, the silt retention pond has been created here, where we see that there is a lake which is adjacent. Now, for that, all the water which is coming before it flows onto the lake, there will be a silt retention pond, so that the silt is not passed on to the natural surface aquifer. In addition to that, we may also have some trenches which will be there, we may have these collection chambers, the rainwater harvesting trenches and pits. We may have trenches which will be taking the water together, and then we may also have different types of the groups of plants which are planned based upon their water requirements. So, all of that has to be planned right in the beginning. Another strategy that we have already seen is limiting the grass turf areas. So, we have to limit the grass turf areas only for recreational areas and pedestrian uses, and where we require soil conservation. There too, the type of grass which should ideally be used is the native grass which is locally available, wherever it is going to be used for soil conservation, so that the purpose is only to hold the soil and not for people to walk on it. So, the soft and the more fancy kind of grass species may not be required. In addition to that, when we are doing that, we should ideally get a soil analysis done. So, we should get the proper soil analysis done, and in case required, the amendments to the soils may be done. For example, if we want to create a retention pond, however, the soil is too loose to allow the water to retain, and it allows all the water to percolate down. There, some kind of amendment may be required, maybe a geomembrane at the bottom of it, or some other treatment where the pond actually serves the purpose of retention pond, or other strategies for that matter. Then, appropriate use of plant materials. So, we have already seen that we choose the plants carefully. We also consider their growth rate. It should not happen that two different plant species were planted side by side, and one, since it grows at a very fast pace, totally overshadows the other, and the other plant grows. So, their growth rate, their water requirement, everything has to be looked at. We also have to look at the invasive species, that the plant is not an alien species. We have to select specific plants which discourage the growth of insects given the type of building that we are looking at. For example, if we are planning a landscape around a school and we want to encourage children to use the outdoors, the open playground areas, there mosquito repelling or insect repelling species may be planted, because the children will be playing outdoors, and similarly for other outdoor areas. However, for a landscape, for an office building, a commercial building, a different kind of landscape may be required. Then in the end, we will talk about and pick up the effective and efficient watering practices. We have also seen couple of them, and we will take them. Besides the irrigation systems, we can also look at strategies which retain the soil moisture, for example, mulch. So, the soil is covered with the help of this organic matter, and it retains the moisture which is provided to the soil with the help of irrigation. Now, all these factors, they have to be demonstrated through calculations. So, the very simple formula for demonstrating the savings, irrigation water savings, is where we have the plant factor, a product of plant factor, the evapotranspiration rate and canopy area, and dividing it by irrigation system efficiency. So, when we compare this base case to the design case, the proposed case, we can actually calculate the water usage reduction in percentages. Let me explain this clearly. So, this potential evapotranspiration rate, it refers to the amount of water required by the plant for healthy growth, and it depends upon the climate. So, it depends upon the climate, the soil and the climatic factors. So, all of that refers and is consolidated in this term as evapotranspiration rate. The next is canopy area, which is the area covered by the particular type of plant. So, it could be the area under the shrubs, it could be the area under the trees, and like that. It is actually the when we draw the landscape plan, so it is the area which is seen in the plan being covered by different plant species. The next is irrigation system efficiency. We have already seen the efficiencies of different systems which we take here, and plant factor, it is dependent upon the water requirement of different plants. So, different plant species, based upon different plant species, this plant factor is varying. Now, the values for all of these, they have been researched a lot, and these values are available through different organizations largely working on the forestry and plants and agriculture. So, we can see the irrigation efficiencies which we can use. We can also look at the plant factors. So, for different types of plants, we have the plant factors. So, suppose we have lawns, it has a very high plant factor of 0.56, while if we look at existing trees, it has a plant factor of 0, which implies that no water will be required. If we look at the native trees and ground cover which are planted later as part of the landscape, they also have a very less plant factor, which is 0.1. So, once we have all these, we will actually put them in the same equation which we just saw and calculate the total irrigation water requirement. One of such calculations is shown here. So, suppose as a base case in the initial stages of the design, we proposed 806 square meter of lawns, 400 square meter of existing trees were retained, and conventional trees were planned as 55 square meter of area, and there was a ground cover which was proposed. Now, taking the evapotranspiration rate, which remains the same because it is dependent upon the climate, we have the effective plant factor which gets calculated from the tables which I have just shown, and then we select the type of irrigation mechanism that we are going to use. So, this one is for a sprinkler irrigation. So, we have a large sprinkler and this is used for irrigation, and accordingly we calculate the water requirement for each one of these. Now, as a proposed case, we change this slightly. So, what we have? We have reduced the total lawn cover from 806 square meter to 240 square meters only, and the rest of the area is actually 566 square meters where the native grass cover has been provided. So, it does not require as much of the irrigation because it is the native ground cover. Existing trees have been retained as the same, and the native trees also have retained as the same. Instead of ground cover, native ground cover has been provided. Once we make those changes and we get the resultant effective plant factors. So, we can see that from 0.56, a large portion of lawn has a plant factor of 0.2, and the native trees and native ground cover, which was earlier 0.25 here, has been reduced to 0.1. In addition to that, we see that wherever there is improvement of irrigation, we will provide that. So, instead of a sprinkler, we have brought in drip irrigation process, which has increased the efficiency to 0.9, and instead of sprinkler, we have used multiple sprinklers. Together, we calculate the total amount of water requirement and compare the base case with the proposed case, and we see that here we have been able to reduce the requirement of irrigation by 58%. On top of this water requirement may be substituted through the water which is collected by rainwater harvesting. So, a detailed landscape plan needs to be prepared right in the beginning with the detailed list of native tree and plant species which are going to be planted, the rainwater harvesting which is going to be taken in, the type of irrigation system which will be employed, and all of that should be reflected in the form of this detailed drawing, so that whatever has been shown through the calculations is actually implemented on ground. So, I will stop here for this lecture on water conservation. See you in the next lecture where we will be discussing about more of such strategies towards water conservation. Thank you and see you again.